Okay, 2.5D cutters, milling machines. So these come in a couple of major formats. We have the gantry and the vertical machining center. So essentially, if you were to look at these machines, the gantry machine has a way bigger work area than the VMC does for the same price. Why is that? The VMCs are designed to be extremely rigid. They're designed to get, a thousandth of an inch level tolerances on metal parts. To do that, they have to be very, very rigid. When you go to cut something, there's a reactive force pushing back against the cutter. You need to make sure the cutter doesn't move or deflect, or minimize the deflection as much as possible. The VMCs are very big and very heavy in order to accomplish that goal. If you're working with non-ferrous materials, which is commonly like woods, plastics, aluminums, those sorts of things, the gantry machine will work, and it will work great. So for most things that people are doing, a gantry machine is fantastic, especially if what you're doing is for decorating purposes or props or things like that. The VMC is much more industrial, so just something to consider. A lot of the shops that do work that you'd be interested in, if you're not getting one of these machines yourself, are probably going to be using some kind of gantry machine. Just to note, if you do look at these machines and you're trying to figure out why in the world are these things radically different in cost, rigidity is why. That gantry machine is also going to weigh a lot less than an equivalent VMC would. Basically, a mill, you can think of it like a Dremel tool that's controlled by a computer. It moves forward, back, left, right, up, down. And that's basically how they work. You have to hold the work down. You have to make sure it's clamped in place and isn't going to move on you. But the operation is pretty straightforward and simple. Now, in terms of their operation, again, we're working with three-dimensional files here. You can do DXF FEGs, but you're going to have to, and basically that's a flat format, but you would tell the machine how deep to cut it, and that will allow you to work with it. Or you're just going to take a 3D model and you're going to send that in. Now, here, you'll notice Fusion 360 is the only thing listed here. This is going to be a CAD CAM, or specifically in this case, a CAM. Once we have our model, we're interested in CAM. Just because you have a model, that doesn't tell the machine how to cut it. There's different ways that it could cut it. It could start in the center and cut concentric rings outwards until it finished the part. It could follow the curvature of the part like a topographic map. There's lots of different ways it could cut. It could use a very small cutter and have to make lots and lots of little passes, or it could use a big cutter and make fewer passes. The CAM program is where that determination is made. It's where you sit down and you work with the program to explain, okay, these are the kinds of cutters I have, this is how I want the part to be cut. Now, if you've ever used a 3D program like Blender or Maya or anything like that, and your eyes have kind of glazed over at all the controls, a CAM package may put you into a coma. So something to think about. If you're going to operate one of these machines yourself, is you're going to need to understand how CAM works. If you're just designing a part and sending it out for someone else to work on, it's going to be their responsibility to deal with the CAM. Now, it is important to know, okay, how do these machines work so you understand the kinds of gotchas you can get into. So these machines are 2.5D machines. So the part on the left, the cutter is able to follow that curvature from one end to the other, no problem. The part on the right, you have this overhang. The cutter can't get in to that overhang section, so it cannot, that part could not be cut on a mill. So an important thing to note. Now, there are other machines, like 5-axis machines, that could get into that sort of work, but that's way more complicated than we're going to get into here. So here's some examples. This brass cylinder, the whole thing is 1 inch across, end to end. So this is a relatively small part. This is a hot stamp. This is designed to work with letter wood. You heat it up and you stamp it. So here you can actually see, these concentric ring patterns around it. That's the path that the little tiny cutter took to cut this part out. And you can see in the letters, especially at the tips of the A and the C, you can see we've got really, and again, this is only, the whole thing's 1 inch across. We have very, very precise cuts, and we have a relatively deep cut. The aspect ratio here is quite significant. All done with one cutter, one pass on the machine, and it makes a beautiful stamp. So for precision, we then have this. This is a piece of tiki trim. So here you can see there's a lot of imperfections from where this looks like a chisel was going through the wood, and you can see where it skipped, and so you have these not perfectly straight lines. This was made on that same CNC machine. So the CNC is extraordinarily precise. If you include imprecision in your art, it will be reproduced precisely in the CNC machine. So even though this was made by a machine, you can make machine cut material look like it was done by hand because all the human imperfections were preserved in the original model file. This is another stamp. This is specifically a leather stamp, a cold stamp. This material is acetal, also known as Delrin. Delrin's a fantastic material to machine. It's relatively inexpensive, holds great detail. Again, you can see, especially in the lower left-hand corner, the path that the cutter took in order to cut this part. And then on the lower right-hand side, you can actually see what it looks like after it was stamped into leather. This is a material called Ren Shape. Ren Shape is actually fantastic, even if you're not using it with a machine. If you were just carving something with a Dremel tool, Ren Shape is fantastic. It is a polyurethane composite. It can be kind of expensive to get because they only sell it in big sheets. But here, this is a mold. This is meant for a chocolate mold. That you would make a polyurethane mold out of this, and then you'd put the chocolate in that. So here, you could, in theory, make this by stacking up laser cut segments. But if you look very carefully at the inset in the lower right, you can see that that individual block element has a chamfer around it, that little angled edge. That couldn't be done with a laser cutter. You could do the different patterns, and you'd have to go in and cut or sand the edge to get that kind of feature. But because the mill has the ability to do depth as well as its XY and cuts, we can get this sort of thing out of the milling machine. This is another example of a great material to work with. This is machinable wax. Basically, machinable wax is normal wax. It's had some additives added to it to make it a little bit more rigid and a little bit tolerant of higher temperatures, because when the machine cutter is spinning and moving through the material, it tends to build up heat. Yeah, also made on a milling machine, made on the same machine as the other parts that you saw, and also a great material to just work with in general. If you want to carve something and you need a big block of it, machinable wax is not a bad choice. So these machines here are really expensive, but these are all completely finished industrial machines. You can get a kit to build these types of machines for much cheaper. You could build a CNC machine for sub $2,000. Avid CNC is an example of a company that sells kits of various sizes. Here you see on the left we have a couple of examples of the gantry machines, and on the right we have a Tormach. Now the third and fourth machines on the right, they're the same machine, and I included them here in this slide because they're the same machine, just with accessories. So the Tormach 1100M plus stuff, it more than doubles the cost of the machine in, again, just accessories for it. It's kind of like if you ever get into photography, you buy the camera body and then realize you need to buy lenses for it, and the lenses could easily exceed the cost of the camera. So in terms of capabilities, those two Tormachs are the same machine. The machine on the right with all the extra stuff, it has an automatic tool changer and a whole bunch of extra accessories for convenience, but fundamentally the capabilities of the machine are the same. This is something you need to consider if you're buying any kind of machine at any price point is, are you going to need to buy additional accessories for it? Because the accessories need to be figured into the cost of ownership of the machine to build whatever kind of part it is that you're trying to get up to. And lastly, industrial sewing machines. Now, people ask the question, do I need an industrial sewing machine? And the answer is always no. If you needed an industrial sewing machine, you would not be asking this question. You have a thing that you need to do that cannot be done by a normal residential grade sewing machine. And we'll get into why. So this is one of the sewing machines I own, the Brother CS6000i. Super popular machine. It has 60 stitches, of which you'll probably use like 4 or 5, and a whole bunch of other features and accessories that come with it. Needle up, needle down control, the speed adjustment, all this wonderful stuff. Cost $210. Okay, my industrial machine, the Juki 1541, costs $1,700 and has none of the above. It's a straight stitch only machine. The only thing that's adjustable on this thing is the stitch length. In industrial sewing machines, these are used in places that are sewing stuff day in, day out. They do not need a machine to do more than one task. If they have more than one task that needs to be done, they buy more than one machine. So the question becomes, well, hey Les, why do you own this machine? The 1541 is specifically designed for heavy, thick materials like webbing. So seatbelt material. If you've ever felt a seatbelt before, if you've ever tried to put a needle through a seatbelt, it's almost impossible. It's an extremely dense weave of material, makes it incredibly strong. If you're wanting to sew heavy materials like leather or belts made out of webbing, I've actually used this machine specifically to make a belt from webbing, then it's physically impossible to do it on that Brother machine. The Brother machine, the needle will just stop at the top of the material, and it makes these annoying beeping noises letting you know that there's a problem here. So You're only going to get into the industrials when there's a specific need for it. Again, industrially, like 50% of almost all 50% of industrial machines are going to be straight stitch only machines. Another 25% are going to be overlockers, or what we call sergers, and the last 25% are specialty machines. So each machine has a designated purpose, and that's it. Whereas a residential machine has all kinds of different stuff it can do. It all comes in one great package. Now, if you do get an industrial machine, it ships like this. So you can see there's this piece of material just to the left of the needle plate. That came with the machine. It was actually underneath the presser foot when I got it. And you can see that there's stitches up and down it. These machines are shipped what they call sewn in. Juki only makes that top part of the machine, that big piece of metal that says Juki on it. That's it. They don't make the table. They don't make the motor. They don't make the knee pad. They don't make the cat. Nothing. They only make what they call the head. So what you get when you get an industrial sewing machine is you're not buying it from Juki. You're buying it from a dealer. So a dealer takes that part that says Juki and they cut a hole in the table. They fit the machine. They attach the motors, the belts, all that stuff to it. And to prove that it works, they take a piece of material and they run it back and forth through the machine a bit. And then they ship the machine with it in there. So you can see that they have correctly integrated it. But what this means is, while Juki might be a great name brand for an industrial machine, you've never heard of the company that made the motor or the table or the drive belt. So that's a consideration. When you get these machines, and also this machine took 3 people to get upstairs. It's very heavy. So when you're considering one of these machines, it's very difficult to take it back for service because they're big and heavy and they'll almost certainly be delivered on a freight truck if you get one. So example machines, the 8700, very, very popular Juki machine. 62 pounds, that's just the head, just the thing that you see there and nothing else, not the table, not the motor, anything. That's 62 pounds, $800. 5,500 stitches a minute. Okay, let's put that into context. That's 92 stitches a second. If you're doing 10 stitches per inch, which is really common, that's 9 inches of material per second coming out of the machine. That is insanely fast. Now, if you sew all day, you become more proficient. But the people that are generally using these machines are sewing the same kind of thing all day long. So their proficiencies become really, really high. One of the things that people get into is they buy these machines, and the very next thing they want to do is they want to slow them down. Unlike the residential machines like that Brother, which has a nice digital slide that you can move to slow the machine down so the foot pedal isn't quite so racy. Yeah, these machines don't have that. And the ones that do, even the minimum speed is still really fast. And because of this, a lot of people will end up buying pulleys. They'll take the pulleys, and the pulleys will basically act as a reduction drive on the belt. They're not the easiest things to install. It's not like you just attach it. There's going to be some screwing and bolting involved. And it's a thing to consider. You might think, oh, I would totally be more productive with this really, really fast machine. Just understand, maybe that's true, and you could benefit from one of these machines. Also, though, if you can't, then the next thing you might be doing is spending more money to try to slow the machine down that you bought because it would go fast. And that's it. That's the end of the presentation. I think I covered all the questions that most of the audience had when I originally did this at MomoCon. If you have any questions about this presentation, leave me a comment. Let me know. Book of Aaron Pages is basically a blog. I think mostly now I just have links to my socials there. But yeah, if you have any questions about this or anything else, let me know. Thanks.